So this video is going to discuss how to test a transformer. In this particular case, I have an oven control transformer that provides 120 volts AC on the primary side, and then breaks that down into 4 separate voltages. So we actually have 4 separate secondary coils. The first coil is a 33 volt coil. The next is an 11 volt coil, and then we have 3.3. We actually have a center tap of 3.3 volts AC. So to test a transformer just with an ordinary DMM, the easiest thing we could do is just do a resistance test. So if you do a resistance test, you want to check all the windings, and what you're looking for is to make sure that there is actually going to be some resistance in each of those coils. And so remember that all wire has resistance. So if you find an open, or if you find a short with very, very little resistance, then that would be a short, and either one of those would be a major problem with the transformer. The only problem with testing for shorts is you're not always sure exactly what the resistance would be unless you have tested it prior, or you find documentation which actually specifies what those should be. So remember, when you're doing a step down, so we're going from 120 volts to, let's just say we're going to the 11 volts here, to kind of make it 120 down to, just call it 12 volts here, would be a 10-to-1 reduction. So that means for every winding on the primary side, for every 10 windings on the primary side, you would have basically 1 winding on the secondary side. And so you're going to have, it's a 10-to-1 reduction going from the 120 volts to the 11, or call it 12. It's basically a 10-to-1 reduction. So you're going to have, because of that, you would expect 10 times as much resistance on this primary side as you're going to have on the secondary side. So you would expect much, much less resistance on the secondary side, because we're stepping down in this particular case, which means that we're going to have much fewer windings, much less wire, and therefore less resistance. The other thing is to remember, though, is because we're stepping down the voltage, so the voltage is going down, but the current therefore is automatically going to go up. So remember that as you with a transformer, you have power in is equal to power out. And so if you had on the left hand side, we have 120 volts. Let's just make the math easy, say we have 1 amp. And so on the secondary side, if we were actually going to say 12 volts, we would have, if we had 1 amp on this side, we would have 10 amps on the secondary side. And so if you're going to have 10 amps on the secondary side, then you're going to need much larger wire to handle that much larger current, and therefore the wire would have larger diameter, which would reduce the resistance also. Now in this particular case, this oven control transformer, we're not going to be drawing anything near 10 amps on the secondary side, so the wiring isn't necessarily all that huge, because you gauge your wiring based on the load you're actually going to connect it to. And the whole purpose of this, of course, this is for an electric oven, okay? And so the oven actually runs off 240 volts to heat the oven. So the purpose of this oven control transformer is just to run the circuit boards, to run the timer, and to set the temperature and you know, those aspects. So we don't really need very much current to do that. So the windings on the secondary side are designed for the amount of current that they would need to feed their load. So they're not going to be very big, as you can maybe see in the picture here. So what we're going to do is we're going to test them. I actually have two of these transformers. One went bad, and so I'm just going to kind of run through and do a quick test of that, and then I just got a brand new one, and so I want to test the new one before we actually put it into place. Now, another way to test your voltage or to test your transformer would be to actually apply a voltage to it and see whether you're getting that return voltage on the other side. So the first thing we'll do here is we'll actually test for resistance and verify that there's definitely a problem with the bad transformer. And then I'm going to apply a voltage, but I'm going to be using a function generator here. So I'm not going to hook up 120 volts to this transformer to test it. What I'm going to do is only hook up 12 volts. So if I give 12 volts on the primary side, right, and then instead of 120 volts as desired, or as not desired but as designed, then you would, you know, that's a I'm only giving it 1/10 of the voltage, so it's designed for 120 volts. I'm just going to apply 12 volts, and so I'm going to test these connections. And as we test those connections, then right, I would only expect 3.3 volts on the 33 volt winding, and 1.1 volt on the 11 volt winding, and 0.33 volts on the very small windings. So let's give this a test and see what we have. Okay, so we're going to measure our our resistance here. So I've got the meter set for resistance, and I'm just going to connect this. I've got some alligator leads here, and then I just got a piece of wire that I'm going to stick in the connector here so we can connect this. And right now you see that it says overload on the meter, and when I make contact here, it still says overload. Okay, so that indicates that this transformer is bad. Okay. Now if I come over here to the new one, and so here's my new transformer, and I'm going to stick in this here, and you can see that it's giving me about 22 ohms, giving me 22 ohms of resistance. So if I was at 0 resistance, I'd be a little bit worried that that's too low. All right, so remember, this is just wire, and so it's not going to have a huge resistance. We're not talking like thousands of ohms or anything most of the time. It's just copper wire inside here, so therefore it's very low resistance, but it's certainly not 0 or, you know, a fraction of an ohm. Now if we go over and look at the secondary windings, okay, so we could kind of come over here and look at a secondary winding. And so we have, like, red to red here was, I think, supposed to be the 33 ohm. And it's not doing a good job of getting connections here. Alright, so if I put on the 33 wire ohm connection here, you can see that that is about 7.7 ohms. So again, it's a smaller resistance because there's fewer windings. And then if we go to the next set of windings, right, I'm down to a single ohm. And yeah, that's a small resistance, but remember, this is just very, very small voltages, and it's copper wire, copper windings, and so therefore, you know, the resistances are going to be very small resistances. Okay, but if I was just to like short these two out, all right, well, it's reading 0.62 with them just shorted out. So, but it's, so we definitely are reading more than just the resistance in my lead wires. Okay, so so hopefully this is good. But next thing I'm going to do here is apply some voltage. So now transformers. This type of transformer is designed for 60 hertz. So I've set my frequency to be 60 hertz. And I've set my voltage to be 6 volts RMS. Now I know I mentioned earlier I was going to do 12 volts RMS, but unfortunately I can't do 12 volts RMS on this, or it only goes up to about 7 volts RMS. So I just picked 6 volts. So remember we had a 33 volt winding, and so a tenth of that would be 3.3, but that would be if I was supplying 12 volts. So I'm actually want to do half of that. So half of 3.3 is going to be, you know, about 1.65 volts. The 11 volt winding should, you know, since I'm only putting in 6 volts, it's going to give me, instead of 1.1 volt, it would be giving me, you know, a little over half a volt, or, you know, 550 millivolts, and the 3.3 windings would give me about 165 millivolts. So I'm going to go ahead and connect up this 6 volt RMS into my transformer on the primary side and read the secondary winding values. Alright, so I've hooked up 6 volts RMS to the primary side, and now I'm measuring the 33 volt winding, but since I'm only putting in a fraction of it, so instead of 120 volts I'm only putting in 6 volts, so I'm reading about 1.7 volts. Right, we calculated 1.65 volts, so it's actually just a hair higher than that, but it's definitely outputting a reasonable valve. Now if I go to the 11 volt, remember it was supposed to be 0.55, and so it's putting out about 0.58, so that looks good. All right, and I'm just going to go across. Well, okay, here is the one winding, right? It was supposed to be 165 millivolts. It's 172. And if I go across the entire winding, right, it's twice that. So this transformer definitely is working at this lower voltage. Now, I guess I would want to say one thing is that sometimes if you have the bad insulation in your transformer, a low voltage test like this may work okay, but once the transformer heats up and is running at full load, you know, it could still actually be bad because you know, as it heats up and the copper expands, it could be shorting out within some of the windings there, right? But I mean, I don't expect that on this. This was a brand new transformer, so. But I just wanted to go through the testing process. So there we have it.